We know that there's a lot of exciting things on the agenda today. There's a lot of really brilliant people to talk to and interact with. So I do appreciate that you've chosen this session, Lighting Innovations, to spend time with us and to learn about what we're doing as individual organizations, but more importantly, what we are doing as a collective group to put into action some of the things our keynote spoke about this morning. Lighting is an action item. It is an activity that everyone can do now, whether you're managing a facility, you're manufacturing a product that goes into facilities, or whether you are a consumer purchasing products for your daily life. Lighting, I like to say, is one of those amazing innovations that very few of us think about outside of the energy industry until it doesn't work. And then you're like, oh, it's dark in here. So thank you. And I do think it's relevant to everyone in this room, regardless of where you're at in your station on the energy efficiency kind of gradient. So, a brief introduction for myself, Kelly Cunningham, Outreach Director at California Lighting Technology Center. You can see our mission on the screen behind me. We've been around for about 10 years. We are part of UC Davis. We're part of the energy efficiency centers there, and our goal is to bring knowledge about lighting innovations to reduce the energy used for lighting your spaces out to the world. We're seated in California. Our first mission is California through our association with the Energy Commission, the CPUC, et cetera. But the global arena is where also we have a participation in that dialogue. Brief introduction of our other panelists. We've got Randy Walthers from Raley's. Chris James from Cree. And Artie Dagani from UC Davis.
Yeah.
So we won't have any campus rivalry enacted in this room, although I guess Q&A is fair game, although I might cut you off if it gets ugly. So I'm going to point you to your program to read their bios, but all of our panelists do have an impressive place within adopting energy efficient technologies for their organizations by either means of bringing them to market, as in the case of Cree, or by implementing them in the organizations which they oversee. It takes a lot of conviction and guts to say, I'm going to take a large entity and I'm going to do the right thing for energy. I'm going to make it worth it, and I'm going to make it economically pencil out. So that's why we brought them here for you today. However, I'm going to set the stage for just a few minutes, and I'm going to talk about the baseline, the standard. You know, we're here thinking about tomorrow, millions of new jobs, innovations, the connectedness of our devices, from lighting to sensors to data, but where are we in terms of the common things? And one of those common things in lighting right now is Title 24. So everyone in this room, I hope, knows what Title 24 is. It's the energy code for the state of California. It's also energy code in terms of a leader policy for the rest of the U.S. It's not that anyone else follows Title 24, but between ASHRAE and Title 24, there sets a precedent that could be adopted by states beyond ours in the future. So I'm going to share a few notes in terms of lighting on what starts in merely a few weeks, July 1st. And one of the questions that I've been getting over and over again is it really going to start July 1st? Because there's been a delay from the initial start date of January 1st. I have no evidence there'll be any more delays. After July 1st, then Title 24 will be in place. So what does that mean? What does that mean to your facilities? What will you see? And I've only got 10 minutes. And this is my picture of my favorite binder, Title 24 knowledge, with all of its dog-eared corners and pink Post-it notes. There's no way I can cover this information in the time that we have today. So I'm just going to give you some highlights and try to tie it to this is the baseline, and then where are we going to go from innovation from there. So. Just a note, Title 24, 2016, the next code cycle, already in planning. Hearings on the measures that could be in place, presenting opportunities or challenges for your organization already started. Next Tuesday, all-day meeting on lighting at the Commission. I'll be there listening to tomorrow's code. I just wanted to let you know that's going on. If you're following it, you should be following it already for the next cycle. So what's new? What's our new standard? If you do a lighting alteration and you touch 10% of the luminaires in an area, like this conference room, what's 10%? Look up at the ceiling, count the luminaires, then 10%, you're adjusting that, some measures will be triggered. You will need to consider where the state is in terms of energy policy, controls, efficacy, etc. at that point. There's so many solutions that I hope that you'll see this as an opportunity to say, do I really just want to do 2 luminaires in this room, or can I make it pencil out to do all of them and add the controls that I have to, and above and beyond that to capture maximum savings. Lighting power densities. In this case, a race to the bottom is typically a bad metaphor, but this is a race to lower energy, which means lower energy costs for you in the future. Lighting power densities for this code cycle are again declining. What's a lighting power density for those who lighting in this room isn't their core? Watts per square foot, our budget. So let me just call attention to a few things. 0.75 watts a square foot for an office area. Not a lot. Not a huge budget. 0.14 for a parking area, parking garage in particular. So what are we going to use to reach these budgets? Solid state products? Definitely. We've got to think differently about how we light our spaces. It's not just take out light bulb, put in light bulb, whether it be metal halide, incandescent, fluorescent. We've got to rethink it. We've got to reach these points. So lighting power densities are going down. But where's the big meat and potatoes? What's the exciting thing that's caused me to put the last year of my life into understanding and preparing for this code change? It's in controls. Lighting is 2 things, and that's it, at the most minimal. You can make a one-time change to efficacy, or you can layer on controls for sustained savings for the life of that system. And then what if those controls can do something other than raise and lower the lights? Give you input on how the space is being used, change temperature, collect other data, function as a security function, tell you where customers are and aren't going in stores, tell you where employees are and aren't going in your buildings. That's where lighting's going in terms of controls. What can we expect to see right now? Well, now I'm going to get a little bit technical and a little bit specific with Title 24. I want to call your attention to Table 140.10e. And go back to this table, learn to memorize, if only one thing in the code, this one. And in the lighting control sections are 130.1, A, C, D, E, B. Oh my gosh, it's so much to remember. I'm going to make it easy in a minute. It's pointing to all of those, 130.1, that center column, adaptive lighting. Systems that change their light output based on sensor inputs from the spaces they serve to optimize building and energy performance when the people are there or not there. Now you can memorize these. What do you expect to see? A, give the people a light switch. Give them the ability to turn it off when they're not there. That's in code, that's still in code. B, bi-level, dimming. B is for bi-level, dimming. The light sources must dim. They must raise and lower. You can't activate, you can't collect, you can't make exciting lighting control systems without the ability to dim the lights. And this one is when people leave, the lights should go off. When people leave in transitional spaces, corridors, parking garages, parking lots, they should dim down when people aren't there. We're not using the space, why are the lights on? Dimming, dimming down. Controls, this section is where these things are now mandatory. We're going to see this in more places. This isn't 2 years ago when I visited this great event, might have said this is what's coming. Now I get to say it's arrived. Look for this everywhere. Daylighting, more daylighting in more places. I'm not talking about cutting more windows. I'm talking about the controls for daylighting. Automated response to available daylight. Encourage buildings to offer daylight and then utilize it when people aren't enjoying the broad spectrum light. Then electric light should respond according to the need of both the occupant and the energy needs of the space. Daylighting controls is under D. And lastly, demand response. If you are required to have demand response in your facility by code, then you must now have the ability to shed lighting power by 15% when you receive a signal automatically. So E, if on your project you trigger E, down there on the bottom, center column, E, you must have demand response capabilities tied in with lighting. So you can see how important this section of the code is. This is where all those exciting controls, area, dimming, controls, daylighting, emergency, is going into effect. And this includes outdoor. So where are you going to see this the most? Stairwells, corridors, warehouses, garages, places with intermittent occupancy now are required to have a system that dims the light when no one's there, raises it up when people are there, and after close of business, it's off. So one of our big action items to reduce energy use is at night when no one's there, if no one's there, lighting off. And that's in code now for the majority of spaces, including spaces where we've for years driven by and seen stairwells illuminated, beacons, bollards for no reason at night. And then also facilities that we're used to having light on all the time, such as retail establishments. You know, it now needs to be off if you're not using the space. So look for that. That's coming soon. If you're managing facilities, portfolios, or making products, this is now. It's time to use those to maximum benefit at the intersection of lighting and energy efficiency. Parking lots. When no one's there, the light should dim. It's something that our director, Michael Siminovich, feels so strongly about. He spent the last 10 years saying it over and over. Parking an area. No one's there, the light should dim. There are challenges. There are obstacles. I realize this, that if it's not financially lucrative, if there's no rate structure in place from the utilities that's been approved by the CPUC to take advantage of your implementations of the code, the baseline, or go beyond that and be an innovator, be a thought leader, then it's difficult to justify it economically. And we're going to hear in just a few moments from some panelists that have struggled with this and have come up with some solutions, especially for outdoor. And lastly, green jobs. The code is now going to require, starting July 1st, if you're implementing lighting controls under the mandatory measures, someone to make sure that they go in properly, or at least help with that process. An acceptance test technician to go into the space and go into the parking lot and say your motion controls are activated, they're working, to help prevent customer disappointment, dismay, arguments. It's the product, it's the system, etc. Acceptance test technicians should be able to help with this. It's both green job growth and hopefully a way to better assure these projects go in right. So the last few slides are just resources. The Energy Commission, always go back to the code and learn it, or contact someone who's read it, like I said, for the past year. I have in my backpack some of these what's new in the code. If you're curious about what else is in the code for residential or non-residential, it's only 8 pages. I have them to hand out.
We'll just call you Kelly.
You could just call me, but my phone has been pretty busy these last few weeks because everyone was, is it going to happen? Yes. So we need to move beyond the strategies we've been using for the past 100 years to get occupants to reduce lighting when they leave the room. We need to take advantage of innovation. We need to celebrate that intersection of connectivity and data with innovation with new light sources. The incandescent era may be dead if they don't improve the product to catch up with what new tools are in the toolkit, and it is a toolkit. So we need to move beyond this 100-year-old example of behavior modification that I snapped a photo of on Angel Island 100 years ago. This was painted on the wall perhaps, and we need to get to something new. And the Title 24 I thought was a great way to kick this off, just to remind everyone that tomorrow is here and this is now the new standard in California, and to challenge you to think about where you can go from that standard, which you should meet, and above that, to be continuing to be a leader. So with that, I'm going to conclude my portion of introductions, and I'm going to hand it over to Artie, who is going to give you an update on what's going on at UC Davis in terms of lighting, and what they've done to make sure that they're ready for tomorrow, net zero, by looking at their building stock today and making some major changes to how they use energy to light those spaces. Artie?
Thank you, Kelly. My name is Artie Degani. I'm with UC Davis Design and Construction Management Office. We manage, just like our name, design and construction for all campus capital projects. Kelly didn't mention that if for some of us the budget project 2 years before the project finished design, we curse the Title 24 changes. We should route those to Kelly because CLTC is responsible for majority of the lighting changes in the Title 24. And those of us that love environment and energy reduction, thank you, Kelly.
No, don't throw darts, though.
Before I start, I thought maybe I'd give you a little bit of background about our UC Davis. It's about 5,300-acre campus, about 1,100 buildings. Many of them are constructed in 50s and 60s and 70s, so they are a little bit older facilities, and you all know what the hassles are with the asbestos and seismic and other safety issues as we enter these facilities for renovation. We got 34,000 students. Our electricity peak is about 46, 47, depending on the year, megawatt. We use about 250 million kilowatt hour a year of electricity. Significant, even with the lower rate that we pay, it's still a large dollar of utility investment in our campus. After looking at our lighting energy with California Light Technology Center during this past 3 years, we've identified our lighting energy is about 20% of our electricity is used for lighting in our campus. Some folks have, different data. 27% we've seen some places. Some places 18, maybe are right around 20. Our electricity rate is low, and we have no time of use. We have a contract with WAPA, utilizing PG&E transmission main. It's 6 cents, 7 cents, depending on the year. Fairly low. So when we apply energy conservation measures, it's really difficult with the payback to make it work. We have added 20% of new facility in the past 20 years, about a little bit over 3 million square feet. But our energy of 93 and 2012 is about the same. So we've implemented conservation, built better buildings to be able to maintain that relationship. Just some of the highlights about energy efficiency, about how we got to where we got. So we did the 1997 lighting lamp replacement. It was really just changing T12s to T8s in majority of our facilities. We had a 2006 monitoring-based commissioning. This is partnership with PG&E Saving by Design program. And then 2009 through 2015, a statewide energy partnership program between UC, CSU, IOUs. It's a program that provided more incentive than Saving by Design program to help us be able to achieve some of these energy goals that we had in mind. Our campus required that our new building or major renovation exceed the Title 24 Part 6 by 25%. We yet to identify what would that mean in 2013 because we're still looking for software to come out so we can do some comparisons. We contracted a 16 megawatt solar array on campus. It's just starting construction. So we see how that goes with this next few months. And before I mention about the smart lighting initiative, we have other initiatives I didn't list. We have biodigester project on our campus. It's a UC Davis technology that takes some of our waste and generate electricity. We have significant energy recovery in our central plant, thanks to PG&E that help us kind of get that in place. It serves 1,200 room dormitory right now. The heat that is captured from the flue gases from the boilers picks up all the heat need for 1,200 bed dorms, and it's scheduled to pick up another 1,200 this coming year once that new facility is online. A smart lighting initiative started in 2010 and currently is in progress, and I'm going to give you a few highlights about where we are with some of those projects that have taken place. So when we started the project, some of the issues, lack of lighting metering, none of us, especially these older facility, 1,100 buildings. So we worked with, take a look at what information we could gather before we go that level, working in occupied spaces. Going changing lamps in people's that, most of us spend time in our office more than we spend time in our living room. So it becomes a personal space. And then you have research folks that their livelihood depends on their labs. So, changing things inside their labs, it's a bit challenging with those folks. With all due right and respect. Delivery method, just evaluated a few. Design and build seem to be most effective. Working with California Light Technology Center to figure out technology. Strategic phasing, trying to figure out how to make the funds work together. And then funding challenges. And the idea was that the energy saving have to pay for the project itself. We didn't have external money, with the exception of incentives through utility companies. I need to move fast. I have 5 minutes, and I'm not very far. This is a little bit about our exterior lights. 3 parking structure, 56 surface parking, 4,200 freestanding poles, and so on. About 5 million, 5 million megawatt or million kilowatt hour we use on exterior. And then we have over 1,000 freestand or building-mounted type fixtures that is really difficult to modify. Some of the goals for exterior lighting, we want it to be fully dimmable. We wanted occupancy sensor at each fixture, wireless control. And a lot of reason for the wireless control was because our conduit is really old underground. It's difficult to put any kind of a control wiring inside, so RF control made a lot of sense. We finished our phase 1. It's a fully adaptive lighting control, mastered by California Light Technology Center, thank you. It's fully dimmable LED Philips. LumaWave control was a bleeding edge when we started. It was in the laboratory of California Light Technology Center, but they were comfortable. It's a great technology to pursue. It had all the functionality we were looking for. And with this project, we shift from the bleeding edge into cutting edge technology on that type of a control. Our saving is about 70% and is a nationally recognized exterior lighting project. Some of you may have seen some article about it. Some of the lessons learned. We learned that LED has to come with dimmable capability. Folks have a hard time keeping up with that light shining on them. So dimming really saved us to work with the user to make sure that we were able to meet some of the user expectations.
You mean they're too good? They're too bright, is what you're saying?
They are really bright, yes. Yes, yes. If it was not for dimming, it would be really unsuccessful project. City of Davis have done some, and it's been problematic a bit. Some of the challenges, of course, training, both for our installer and operation and maintenance folks. That is also offered through CLTC. That was really helpful for us to kind of get a grab on this bleeding edge technology. Our phase 2 is currently out to bed. It's the second part of freestanding poles. This is just a highlight about energy saving. We're about 62% of those that we implemented, and we hope that phase 2 would continue. A little about interior. On the interior, we did the easy ones. We went to 840 bathrooms on campus and modified those with controls and fixture modification, and then worked on a stairways that is fully dimmable stairways, and it goes way down when it's unoccupied. And it really helped with the occupant to sort of bring him on to this new approach inside facilities. So we started phase 2 in 43 building, about 2.5 million square feet. It would save about 5.5 million kilowatt hour, and the payback is about 12.9. But as we went through this with a contractor called SmartWatt, it was decided that it made a lot of sense to integrate these into mechanical systems. So if we have occupancy sensor and we have a VAV system, can we reduce both of those down? And that reduced the payback to less than 10 years. It's through a change order, so it would have been more effective if we had the money to implement during original contract. Unfortunately, fund was not available. Some of the lessons learned, occupied facilities. We had one lab person that said that if you're gonna come to my lab, you either need to bring police or you have to walk over my dead body, because I will not allow you to enter my lab and modify anything, because that's the livelihood. But then we had many that really have welcomed the controls and lighting in our spaces. HVAC integration we talked about, remote access and training, working on those. Moving on, a little bit, just the high-level information. Our goal is 60% of reduction of baseline 2007 for our lighting energy. We are at 21%. We still have 40 or 39% to go. So hopefully we get there this next couple of years. Our phase 3 and phase 4 are in planning, not funded yet, looking for helping hand. Just quickly touch on some of our partners. Of course, UC Davis Energy Efficiency Center, California Light Technology Center, Sustainability Office. The student body, those students have been great to work with, excellent. A lot of our inventory, a lot of our interaction, a lot of our outreach have gone through the student into campus, and it's been an amazing experience. Facilities management, capital resource, and of course our office. These entities, the CPUC, the PG&E, and CEC, have been great with the incentive and a helping hand to make this project work. Microsoft just joined us to collect data and help us with the analysis, but we're not there yet. Of course, construction, we have those of our contractors and lighting providers, and also our consulting firms that helped us. And with that, thank you so much.
Snuck in there.
So we're going to hold questions to the end till Q&A. So hold that thought, saw that arm. Next, we're going to hear from Randy from Raley's. So UC Davis, a massive project, a small city's worth of lighting upgrades. And now Randy will present more on the distributed city, where he has stores throughout a very broad territory, and give you the perspective of someone who works in retail. So. And one of the things that tying Artie's comments back to our initial introduction with Title 24 that is brewing in everyone's mind is, how do you do when you have an organizational mandate 25 or 30% better than Title 24 using the old thinking? And so perhaps afterwards, if you have ideas on how your organization is going to approach this, then that would be something to discuss with me, because I'm collecting that. Randy.
Good morning. Yes, I'm Randy Walters. I'm the energy manager and utility manager for Raley Stores. And Raley's is an independent grocer in Northern California and Nevada. Being private, I am given the latitude to research and test new and innovative and forward-thinking energy-saving concepts. With Raley's, we have a vision, and a vision which I really like is our vision is I can be fearless and inspiring. Everything else comes into play. But in that, we can move forward with a lot of new projects. As one of the nation's top energy efficient grocers, we are committed to the environment. We have a lot of firsts in Raley's. Raley's over the past have not spoken about it, and we are now trying to pat ourselves on the back because there's so much deja vu. We're doing this now, we did it 10 years ago. As you can see, we were EPA's Energy Star first grocer in the nation in 2002. We are the first to have the Stratospheric Ozone Protection Award from PG&E. We had California Flexure Power Energy Efficiency Award in 2006, and so forth. We also had the first, in 2006, Energy Demand Response, where we developed our own Energy Demand Response program to reduce energy in all our stores at a single command. From 2009 on, with the energy crisis and everything else in California, the energy economy going down, energy costs going up, new construction is on a hold. California regulations, as we know, what do? And I think in 2008 Integrated Policy Report, I think it said it best, that building energy efficiency standards are the most cost-effective means to achieve energy efficiency. Expect the building's energy efficiency standards to continue to be upgraded over time to reduce electricity and peak demand, but also overall savings to the consumer. Where we learned from the past, in our 70s, our stores were bigger, brighter, energy was no problem. We had 1,000 watt incandescent lights. I remember changing them out and when they were about this big around, you try to change those.
You got burned, Mark.
400 watt mercury vapor was the next. Then we went to the 80s. We're being more eccentric. We were the Vegas effect. We had lights shooting up, lights shooting down, lights shooting over. Our stores were over 150, 200 foot candles, blinding. But we came out with a new control system, a dial-up modem. Boy, we can dial up our stores and do the changes. The 90s, the rising cost of energy now, the environment, new regulations now being looked at. Reducing our energy uses came to the forefront. 320 watt pulse starts, induction, LEDs were just being tested. First generation electronic web-based controls are now being used. For all those who lived here, we all remember the 2001 energy crisis. Flawed regulations, price manipulations, energy shortage, rolling blackouts, Enron and Duke Energy. And I became Raley's first energy manager. My philosophy, though, is not to fight the regulation. Embrace them. Get out in front of them. Surround yourself with smarter people, as I do. And don't be afraid of making mistakes. But my best one is trust and verify. As a grocer and end user, I have all these black boxes all the time telling me what I can do and save money. You need to try it, trust, and verify the results. You have to prove your results. Since 2000, Raley's average energy man was at 480 kWs. Today, we're averaging under 280 kW, about a 40% reduction. Now, on topic about what I'm talking about is Title 24, Part 6, the exterior lighting. We did tests and results in our first parking lot in West Sacramento with Cree and PG&E. The total parking lot area was equipped with 16 320 watt metal halide fixtures. To start this program, I went ahead and washed and relamped every one of those fixtures to get a balance to make sure we were comparing apples for apples. We replaced half the fixtures in the parking lot with a 149 watt LED light. Light levels were still right around 1.9 foot candles, half the wattage. And then the furthest lights from the store, we put on a bi-level occupancy sensor. Now this was, 8, 10 years ago. This is before anybody really thought of LEDs then. And we were down 15% from we reduced our load 85% on those lights. As you can see before and after, the ones on the left are your metal halide, the ones on the right are the LEDs. Kind of a little scenario to that, we are saving $3,000 a year on this, and we verified that. We took this store, and the store had two main entrances to it, a single store, one parking lot. And in that parking lot, we watched customers come in and park whatever side, metal halide or LEDs. Even though the LEDs did not reflect as much as the metal halides, everybody parked on the LED for the reflection and the safety and security. Our next one was a full C store that we retrofitted in Galt to prove that LEDs. Our cost was over $4,000 to retrofit from T8s and metal halides to LEDs. We had a simple ROI in 11.9 months. What I do is do actual savings, and the top is actually KWH savings, but I say verify, and this is what our executives want to see, is our actual cost savings. As you can see on the bottom graph, the red one here, the black one going down is our actual savings. Back in January this year, period 9 is what that is when we did the actual retrofit. As you see, we've dropped 40%. Our first full LED complements a Cree in our South Lake Tahoe store. Additional cost of that store has cost me about $14,500 more to make it a full LED store, all with controls and step-down dimmings. We have an average lifespan, 70,000 hours, 10 years. Simple ROI was 19 months. Life cycle savings was $75,000. It's a no-brainer. I do a comparison with the like stores to make sure we are seeing the savings, and as you can see, we're 20% lower than a like store right now. Title 24 challenges that we have. If it was up to Raley's, we would change every parking lot there is. But we have is to dimmable on our parking lot. What we have is, we do not own all our centers. We are the title tenant or anchor tenant. Doing that, we do not have the control to go out and change. What we have to do, though, is kind of force our project managers to change it for us. There again, it's economics for the property manager. They get a percentage of pay while they're working. If they pay a $3,000 energy bill, they get 10%, that's $300 in their pocket. If we reduce it down to $1,000, guess what? They just lost $200. It's hard to force them to do it. So my theory is we have to force them. What we're doing in our main office right now, we're looking at is the second part of forcing property managers or owners to do the work is the controls, as we were talking about. Controls are very essential to exterior lighting. Without controls and improving our parking lot lighting to LEDs, we'd have to dig up the parking lot, run new wires for 0 to 10 volt controls. So web-based wireless controls are the future. We're looking at a GE light grid system where from my office, it broadcasts out, it hits one light, it broadcasts the other light. This grid nodes are GPS controlled, bi-level or dimmable, 0 to 10 volt, integrated into the fixtures themselves. With that, we can have full control of our parking lot, keeping the parking lot lights front of the store, close to the store, a little bit brighter, the further ones out, a little bit dimmer as needed. My conclusion, always test and verify. There are a lot of black boxes out there. They say they can save and do almost anything. Be cautious. Make long-term commitments. Maintenance and your replacements 5 to 7 years down the road can really bite you, especially if you have numerous sites. Challenge your property owners. Manage to do the right thing. You're the one paying for it. And Title 24, although it's a government regulation, it is one regulation that we can actually see a long-term cost savings if you do your homework. Thank you.
So Chris is getting his slides ready for our next speaker. I just wanted to call attention to the savings we've seen so far. It's not 10%, it's not 20%, it's 60, 70, 80. Occupancy rates have never been measured before in parking lots, corridors, stairwells. We're seeing rates of 10% in a corridor in a busy facility. On a stairwell, you know, how many people actually use the stairs? So these are big savings, and they are paying back. As you saw, you could say, well, this sounds great to be an early adopter, but how long is it going to take to realize your investment? And I think Randy's case studies just showed that it doesn't have to be long. But it also challenges everyone in this room to think about some of these barriers. There are people out there who are being incentivized not to do energy projects. How do we change that? And with that, I'm going to turn it over to Chris, who's going to talk about what Cree offers as a manufacturer.
How do we get them to do it? Well, let's take that one head on. So some of you know Cree, some don't. So let me give you a quick 2-second overview. We've been around since 1987. We started as a semiconductor firm, did a lot of research for the Department of Defense on 2 very special materials, silicon carbide and GaN, gallium nitride. And what's happened after 20 years of development and a lot of scientists and a lot of money, we are able to do things like light up the front of the San Francisco International Airport. That's all us. So one of the things I want to get across today, too, before I even get to the economic argument, which is really our primary argument, is just show you that LEDs are ready, because in most audiences I go in front, they're thinking, LED flashlight. Yeah, that's good, great, love flashlights. We're a little bit further than LED flashlights today. Put it this way. All right, there we go. In the last 10 years is really what I'm going to focus most of this on. It's been pretty good for our growth as a company. That's a pretty good Silicon Valley looking type curve. We have $1 billion in the bank in cash. We have no debt. It's all from LED lighting. We're having a pretty good time. That was last June's numbers. We'll publish this year's numbers in about 2 months, and I think they're going to be a little bit higher. I'm not sure, not allowed to say. I don't think it went the other way. So, no, things are going great. And one of the things that I heard somebody talk about the challenge, well, the governor talked about challenges of jobs in the U.S. It's really a Silicon Valley mentality that's made us who we are today. It's a relentless mentality on innovation, because if you don't eat your young, somebody else will, and we all feel like that every day. It's the Chinese, the guy next door, whoever, you have to move faster. So one of the key metrics we have inside of Cree is a momentum measure of have we released something that's the best in the world or something nobody's ever seen every 2 years. If we haven't done that, if we're not on track to do that, all hell breaks loose. We start changing things around, we change people around, we move buildings around, things change because we have to do that. So on this chart, the last 10 years, you'll see things that didn't exist before are all #1 in their class, including that little bulb on the lower right-hand side that's now 14 months old. We're the #1 SKU in Home Depot. We're the #1 supplier for Home Depot. Nobody expected that, including us, by the way. And you can buy those lights in the US where they're rebates about $3 a piece, $3 to $5 a piece. I'm not sure in California, haven't gone to go check it.
10 to 5.
After the 10 to 5, $10 down to 5 after rebate. So it's closer than people think for a light bulb that will last, well, I'll show you the data. It's more than 25,000 hours that we have to put on there. It's a lot longer, and you'll see more about that on a sustainability and duration basis. It's pretty good. So momentum's a big deal. We focus on that a lot. And to prove it, one point about what's happened, this chart in some form or another existed in the 90s. The Department of Energy developed it originally. And what it really shows is the other technologies that we all use for lighting, tube-based technologies, have been stuck in efficiency for a long time. They're 130 years old, conceivably, for the incandescent, and they're 60 years old for the fluorescent. They're going to go up maybe a few percentage points, but essentially they're flat as a pancake. And to a strategy guy like me, I love this. You've got the enemy corralled. They can't do anything about it. And you know by device physics that the potential for efficiency of LEDs could go up to, well, actually 10 years ago, the official word was 200 lumens a watt was the theoretical limit. Oh, we're wrong. We're already at 280 lumens per watt in production today. We've just demonstrated 308. We're not sure what the theoretical limit is now, but we're getting pretty close. I mean, now we know it's not a lot more after that, and then controls are the next step. So anything you see in this chart, you put simple controls that they've been talking about here. Is there somebody in the room and moving? Is the light bright enough that we need to turn our lights down? You do those two things, you knock off another 50%, which is effectively doubling these numbers. So we are really in the 400 lumens per watt range right now with the controls we have in our lights. And at the same time period, this is the key. This is something we've really focused on, dropping the cost of making LED lighting, especially through the LEDs. So this is 2006 to 2013 data from our factory. And that 100 is not dollars, that's just percent of the cost. We don't like publishing our cost of things. You can imagine why. But we've dropped it basically 97% since 2006. Get your head around that, right? It's partly process design. It's partially product design. We've changed the nature of the packages. We've changed the products. We've changed where they are made, what parts made where. 97% in 7 years. That's pretty tough to keep up with. And we knew we had to do that as a foundation to really break through the adoption curves that we wanted to. And then we were going to load them up and make them look like an iPad, and I'll get to that in a minute. And we're on that track. The other thing that's really interesting that people don't know, because we haven't published this graph until about 1.5 years ago, is how long LEDs last. So if I ask somebody, how long do you think an LED would last? Probably people would say, oh, I don't know, 25,000 hours, that's a lot longer than a bulb. Well, this is real data from our production of LEDs from 2 years ago, and it's the same methods we use for the Department of Defense reliability testing. So it's pretty darn certain. It's the stuff you launch Voyager with and Pioneer, and you put it in space, and you bomb, well, I don't want to say bomb people, but anyway, it's very reliable mathematics. And the latest curves, this is a log curve for those of you who are not used to engineering graphs. That number over there is 1 million, and that's 1 million hours. 1 million hours, okay? So we are pretty darn sure that at 1 million hours of use of our latest generation of LEDs, 30%, it means the way this is measured is if the light output is 30% down, we call that end of life, which isn't accurate, but it's a convention in the industry. 1 million hours from now, those things will be down 30% from their original light output. That's 100 years on 24/7. Everybody got that, right? So now what fails? Well, lights don't last that long for other reasons. Part of it's transformers, part of it's accident, part of it's lots of things. We're not really worried about the lifetime of LEDs right now. At least we're not. Some people are, we're not. What does it want me to do? What is that? Make that go away. I'm not the IT guy, but fortunately, Cree's IT guy is right back there, so in a pinch, he'd come up and help me. So as we've been changing a lot about the product, and we've been changing a lot about other things, we've also been changing how we go to market, and I hope this is there. And you may have seen some things like this in the last year that we never would have done 3 years ago. But all of a sudden, when you're trying to get people's attention and let them know what's changed about the world of lighting.
Today we lay to rest your creation, the incandescent light bulb. I know you're not shocked, sir. You knew that it needed an unreasonable amount of energy to do its job and that it had the lifespan of a lucky bug. The Cree LED bulb is a worthy successor. So it is time. Good night, sweet prince.
That's pretty edgy for a semiconductor firm. And we have a whole series of these. I have another one I was going to show, but I think I'll just keep going. That is part of this. You get people's attention that something's changed. We went from nobody knew who, hey, stop. We went from nobody who knew who Cree was to a household name pretty quick. And so if you put all this together, oh boy, I definitely am challenged today. Yeah, right there. That ought to work. Okay, so what this tells you is now lighting is not a bulb. It's not an expense item. It's a capital asset that'll last 1,000,000 hours. Well, that's different. Maybe you could finance it with capital asset financing, like maybe leases, like maybe long-term financing, like maybe hedge funds are interested in 30-year returns. 7-year problems, you're not going to have them. It's going to be there in 20 or 30 years. That's great. You turn them on and you finance it, it generates positive cash flow. This one is hard for people to get their head around. You turn on an LED light in a project that you financed with a lease, you make more money than at anything costs to service the lease, you make money. It's like growing a division without people, headaches, products, markets, marketing, lawyers. It just makes net profit, just do it. In fact, we've got to the point where I'll go to a public, not very often, I'm pretty careful, go to a CEO of a public company and say, if you don't do an LED lighting project, it's malfeasance. And you're incompetent because you're withholding known cash flows from your shareholders, you should be fired, and we're going to talk to your board of directors. What do you think of that? The conversation gets pretty funny right after that, but anyway, we're doing things like that. Prices really don't matter, it's the cash flows we're trading. And lighting is no longer a product that's sold, it's something that fits into your regions and territories, and I think Randy's given some really great examples of what we'd like to see more people do. He's way ahead of the curve. I mean, way ahead of the curve. And it also opens up to all kinds of new things like how do you sell? We don't have to use lighting agents necessarily. We can go straight to Stanford University or the city of San Francisco, or how about the federal government, the GSA, that owns 3 billion square feet of real estate, and say, we'll do it all for you. And we've got partners that'll install it, and it'll be there for 30 years, and we can put it on lease. When do we start? It's really a completely different conversation than what we used to do. Just to show you what's going around the world too, 2008, the Olympics, we did the whole thing. Every lighting venue in the Olympics we did. Los Angeles, every street light, 140,000 Cree LEDs, 8 years in, they hit all the predictions they'd expected, and much less on the maintenance. Can't bug. By the way, I just noticed this is the same, I think it's the same parking lot, isn't it? That was several years ago. That's a McDonald's, 97% LEDs. The only ones that aren't are over the fat fryer, and it's a safety code. Retail, we're in lots of retail stores. Turned selling cars at night upside down because you can see them better. Stanford Court Hotel. If you think LEDs aren't ready, let me show you some more pictures later. I mean, we've been doing this for 8 years now in the market. They're ready. But what's most important is what's coming next, which is it's the connected world, and all the things we just talked about here, we're assuming you couldn't put all those sensors and transmitters and receivers and cameras and anything else you want in a light, but you can. So you take your favorite tablet, whatever that happens to be, turn it upside down, open up the back, take out the LEDs in here that are backlighting LEDs. They're about a 50th of the power we use for lighting. Put in lighting LEDs, close up the cover, stick it in the roof. That's where we're going. So you have a web-enabled, app-enabled, RF-enabled, Wi-Fi-enabled, logical monster in the ceiling and on the streets that all talk to each other and that all talk to the building control systems that are already there. You don't have, I've affectionately call them the climbing wall. If you look at all the cable companies' ads today, they want to be your security vendor, they want to be your building management vendor, and they all want you to put sensors on your walls in every room and on the ceiling. Oh, that's great. It's going to look like a climbing wall with a bunch of wires. You're not going to do that. And commercial buildings aren't going to do that. They can do it right here, except it's right there. So we can replace all this stuff in commercial real estate today. That, I can't tell you the exact schedule on some of this stuff. You've seen some of it if you watched our releases in the last 4 months, because it started. Now we have the networking done for commercial lighting. And if I walk out the door, go to a street light and put on something from Silver Spring Networks, which is down the street, and something from Qualcomm, what's on top of that, I have a controlled network of lights on the highway. Done. So stay tuned. It gets interesting very, very quickly, and we want to be right in the middle of it, because the impact, I'm going to skip a couple, is huge, especially if we can get a policy shift on how utilities go to market with lights, because they're the natural channel for selling lights, really. They touch every light on Earth, and they could move a lot of product through the way they administer stuff like PG&E does, and we'd like to see more of that. But the DOE's published for 15 years now that if lighting, which is 19% of the grid, 19% is lighting, LEDs will cut that in half by 2030, and they've been publishing this data for 10 years that I know of, and they've refreshed it every 2 years. That's 40 nuclear power plants, okay? You put controls on those LEDs, now you're down to 5% of the grid. You just dropped 15% of the grid in one whack. Oh, with this stuff, we're now connected to the HVAC side of the grid, which is another 30 to 40%. So now, if you could drop that with the demand response programs with utilities, you've cut off the peaks that we're scared to death about for rolling brownouts. You've lowered the base so you don't need new power plants. And we're in a completely different energy situation, a completely different security situation for the United States. It's a very different game. And that's what CREE wants to be right in the middle of. And we work a lot with the DOD and DOE to try to get there. So stay tuned, it's going to be fun. Did I beat the time? Was I under? No.
No, excellent. Thank you. So, I hope you've seen, or maybe you already were a believer in terms of what lighting can do, but I'm hoping that you'll see it now as even more of an action item to realize some of the things that we will hear about today and that we did hear in the keynote. So for the rest of our time together, which is about 15 minutes, right? We now can open it up to you for what questions you have for our speakers today. Large end users, producers, leaders, what's next? I think it's all fair game. But I'll also say that if we get too far into a discussion, we'll have to table it and we can follow up afterwards. So let's begin. And
If people could use the microphone.
You could.
It's being recorded, so please.
Sorry, forgot about that. Yeah, so if you could queue up and use the microphone, you've got to stand. So whoever gets there first, go. No, it's equal opportunity in the efficiency world.
Glad to hear that. It's on, right? Well, nobody's ever accused me of being too quiet, by the way. My name is Paul Grant. By trade, I'm a physicist. My professional life was spent as a basic researcher at IBM Research Division, and then as a science fellow at the Electric Power Research Institute. In fact, the LED array that you're holding in your hand was invented by IBM, and I was part of the effort that led to that. And I also funded a little bit of CREE's work in advanced wideband gap semiconductors when I was at Emory. But, here's what I want to bring up, a kind of a dichotomy. And you're selling energy efficiency, and that's good. I grew up in the Hudson Valley in New York. My mom worked for the local utility company from the age of 16 as a stenographer, and she retired as the secretary to the CEO. And she would yell at me, "Paul, turn the lights out when you leave the room." And I would wonder, "Hey, Mom, don't you own some stock in Central Hudson? Shouldn't we be using more electricity?" And she would say, "I don't care. Turn the lights out. Do as I say." So my point is, with the growth in energy efficiency, and lighting is a very good example. The statistics that you stated in the meeting, I remember this being studied at EPRI as well. Are we seeing final days of Samuel Insull's regulated public utility? Because utilities are not money. Now, I know that's a cosmic question, probably.
It is, and not being representatives of the utility, I think we all might hesitate to say and answer.
Yes.
Although at the very table I was sitting at this morning, a representative of the CPUC was there, and I think that question is best answered by the CPUC and the utilities, but at the same time, I think it brings up an interesting point. And it also reminds us that in each of our states and utility territories, we're grappling with very different models. California versus Texas, other parts of the United States, the Midwest. And I hope that we can come to a common pool of resources, but there won't be a one-size-fits-all answer. I do firmly believe efficiency is best for both parties, and that utilities are revisiting their profit model and how they generate profits or generate innovation in future infrastructure, considering efficiency as the way we have to go for energy independence. Gentlemen, do you have anything that you'd like to say?
Well, one thing is a really interesting point, and there are a couple crises happening right now that are going to help. I don't know when it'll change, but a couple of things have been fomented. Manhattan. Manhattan's basically powered by one nuclear power plant called Indian Point. It's has been scheduled to be decommissioned for 40 years. All of a sudden, for some reason, people woke up and said, gee, that's 2 years from now. So in 2 years, the power basically source for Manhattan goes away, and NYSERDA is panicking. And 1 month ago, they released a rebate for 50% of a project that reduces energy off their grid. Any energy reducing project, 50% of the projects. It's not of the LEDs, it's of the installation cost, the insurance you have to buy, the whatever goes into this thing. They'll pay 50% with no upside limit. So, we're kind of thinking, oh, this is great. We just need a few more of these. And I think that'll help. So there are other pressures that are coming along as well. It's not just efficiency itself is hard to sell, to change the entire structure of the public utility system. But a few crises like this, not all bad. Shooting at the cans up in the northern part of the bay, I guess, for PG&E is not a great idea, so I'm not encouraging that. But other crises are good.
Thank you very much.
Yeah, this question's for Randy. I liked your comment on how, some of your facilities are not owner occupied, as in, leasing the facilities as many businesses do, and you had trouble kind of, and it seems like in many cases overcame that, but getting the owner of that property out of their seat to let you do these upgrades. Is there kind of now a standard protocol that you've worked out with several of the owners of your buildings to be like, we'll give you 10% of the savings if you let us, save X amount of money? Or is there something that gets them out of their seat, or something that makes them move? We're finding in the solar industry that we run up with our customers that really want to go solar, but they're like, hey, our lease is 3 to 5 years or 7 years, and your technology is going 20 to 30 years. It doesn't match up. So how do we get those owners out of their seat for revenue streams that could be in their favor?
Well, basically, it's the bottom line checkbook. We write the check, and that's what I push on to our property managers and owners. Most of our leases are 20, 25 years out, so it helps us a little bit more. On the leases that we have that are 5 and 10 years out, we do have a problem with that. Sure. So that's where our real estate will work with them. Okay, if we move forward with this project, we'll extend our lease, and we do a lot of negotiation that way.
Okay.
I'm Oracle. By the way, very good session, very good presentations. I have a question for Chris, and if I can have your first slide that you showed, where you showed the compound average growth rate of 20%.
Of CRE?
Yeah.
You want me to put it up?
Yeah, can you please want to bring up one point there?
She knows as well as I do now.
Probably better.
So if you're an investor, you're going to say, why isn't it higher? I can't say anything.
If you look at that slide, for the last several years, you notice that the LED products has not changed very much. Why is that? There's so much potential. There's such a positive cash flow and all kind of reasons. Why is it going faster than that? And is it the same for the industry as you're seeing, or there are other companies coming up to make it out? Or what can we do as a users to grow it up? That's the question is. It should be there.
Oh, well, thanks. That's great. I mean, that's not what I thought you were going to ask. Well, it's a more complex question. And some of it I can't say because I'm not the head of investor relations, but some of that's choice. So the green line that's growing is our lighting systems business. That was a choice we made because the industry itself wasn't moving as fast as it could. And we started out, we really meant it as a punch in the eye. We knew we could make better lights than anybody did, so we started making them and said, look at this, you guys, don't be idiots. We don't even understand lighting, and we're making better lights than you are. And they kept growing, and people kept buying it, and the other guys still weren't moving fast enough. So essentially, we started consuming our own production of components for our own lighting because it was getting that big. So some of that shift is our own decision, where we're going. And in our part of the LED world, we have a giant share of it for the part of LEDs we care to make. But the LED industry, if you look at the numbers in that, it's staggering how fast it's growing worldwide. Oh, these are giant numbers. It's just that ours are a large part, a choice of ours to stay in our strategy.
Thank you.
I'm Ray Martin. I'm with a startup in Silicon Valley, Advanced Lighting Technologies. We're developing LED driver technology. I want to say thanks. Great presentations all around. I was curious about the trend going forward in costs. So actually, one of your next slides, Chris James, you said 97% cost reduction in the last 7 years. What does the next 7 years hold for that trend?
Well, so we saw that we're pretty good at predictions on factory-related stuff. About 3 years ago, myself and the CTO started messing around with this. We go, we're going to flatline in cost and efficiency in about 3 years, even with controls. Oh, that's good. Now what do we do? So some of the genesis for more electronics that help the smart grid overall was a realization that we make great stuff, and we've been selling on cost and efficiency, which is great, but once you flatline, other people are going to find you. In the Silicon Valley, they're going to find you one way or another. And that was part of the expansion into other things. And what was a natural extension for us is lighting and smart gritty things and connected everything. And gee, it's just chips we're really a computer at this point. And then we knew the strategy would extend from there. But no, you're right. You see a curve like that and you don't take action, that's called you're going to be out of business pretty soon.
Hi, Susan Wazakis. I'm a project manager here at Stanford, and I had a couple questions. One is the new Cal 24 coming up July 1st. I know you're probably getting all the calls, and we're making them to different people because there's a lot of confusion as to how it is. Do you have any suggestions on places that can support understanding what's coming up?
Well, actually, there's a statewide call put out to the utilities, especially for this code cycle, to make information more accessible, more understandable, and to support education from a facility manager's perspective and from the building department office that essentially has the final say on whether or not your project meets code. So I would point you in the direction of energycodeace.com, to PG&E, or to your utility local might have some resources as well, but definitely to the investor-owned utilities and their programs for education. They've been deploying workshops where they could send experts to an area to say, okay, let's lay it out, let's work through it, and have offered online training for when budgets are tight for travel. So I would say CLTC, we've got guides, we've got webinars, we've got videos. That's a good place to start. I'd also not want to diminish the value of the Energy Commission's hotline. They, this year, have been very adamant about making sure that that's staffed. And it's one person's opinion on the other end of the phone, but if you email, they get in kind of a managerial input for tough questions, so that would be another resource for you. But I hope you'll find that our tools are somewhat helpful and I can answer some questions. Just give me a little lead time on that inbox in the next few weeks. That would be one thing.
Yeah, I appreciate that. And the other thing is on lighting controls. and it's, we're moving forward with all the, the new lighting, that's been great. We've struggled a lot more with controls and control systems that are working properly, and so we put some in, and then when you struggle with them, there's some resistance moving forward. So I don't know if anybody has any suggestions on how to move forward with that new technology.
Yeah, and I think that's an excellent question. That was going to be one of my wrap-up questions. So I'd love for our panelists to address this. And if I can, dissect your question maybe into two parts. I mean, as a facility manager, you've got to specify, install, and manage. But then as a leader for a group of buildings where you have occupants, you also need your occupants' acceptance and buy-in to the strategies. So do you agree that both of these parts of the question might be something you would like addressed?
Definitely. I actually have an award-winning building for controls that the controls don't work properly.
Okay, so maybe we'll start with Artie and Randy and then Chris in terms of what you're supplying. So on the campus, in the stores, how have you dealt with challenges to implement controls? Who do you rely on to make sure they're done well? And then also, what do your students, staff, faculty, and customers think about these decisions?
Well, for us, we definitely share your pain. We did daylighting control in couple of our buildings, and it was problematic to make those work, and a lot of it had to do with commissioning and testing, training, maintaining, all of those elements sort of played a role. So what we did in those regards, sort of work with manufacturer and operation maintenance folks outside the contract work to see if we can make things work, and it's been successful. Our exterior lighting project, it's, as I mentioned, it was a bleeding edge technology with RF control that was not tested in that bigger picture. So it took us approximately 6 months, but California Light Technology Center really was a main point to sort of help us navigate through that system. So definitely there are challenges with the lighting control, testing and commission and make it work, but it seems like the technology is getting there. I think network lighting it's like energy management system in 70s. It took us a long time for energy management system to get up to speed. But another pain, I think, is technology that organizations like ours and yours are going to be here for years. And then you purchase a technology that in 2 years, it's completely different. We probably would have implemented all of these security, integration into mechanical, wireless technology, all of those things that Chris mentioned, we probably would have implemented in 2010 if those were available, but it's sort of getting there. So for us, phasing those projects has been really helpful to be able to at least get some of those newer technology into other facilities and try them. So.
Yes, at Raley's, we have the same difficulties as far as wireless or wired controls. Putting all your eggs in the same basket is really hard. You try to keep it common throughout all your stores. That's almost impossible as companies come and they go. We were almost dedicated to one company that went under or was bought out by another company and closed. And so we now are catching up with the new wireless. We went to look at our own controls, trying to do it in-house, impossible. So we went to CLTC, and we're designing a new store right now, a fully controlled, automated skylighting, louvers, lighting, dimming, the whole package. But again, CLTC has been working with me for almost 3 months, 4 months, just writing the algorithms to make all this work. Is it going to work? We don't know. Our first test store is going to be up in Nevada, so it's outside of Title 24, and so we can open that store up and move forward. But our big store coming into California, we want to make sure all these work. Again, with Crease, self-contained lighting control sources, and what's out there and available today, the sky's the limit. But there again, I have to go back to where it's going to be replacement later. Is it viable? Is it easy to replace? So many different controls are 24 volt, 60 volt, DC, 0 to 10. We just got to make it simple, and that's what my main thing is trying to keep it simple, stupid. And that's the old KISS program, and I try to do that.
So before we move on to Chris, who might address, how can we make it simpler, easier, just answer a yes or no. So has it been worth it to do the lighting controls projects that you have done in the past 5 years? Was it worth it?
Most definitely.
Artie?
Absolutely.
So there are challenges, and if you're considering for your partners, clients, or facilities lighting controls, one of the benefits of hearing case studies at conferences and in-person gatherings is then you can learn from their mistakes and learn from their great victories. So hope you'll use these case studies and the numbers associated with for your own projects. So Chris, are we getting there? Are we getting to the KISS model, or what does that even mean for the connected future of lighting controls?
You're all going to think we set this up this way to feed this to me. So, we're right, we've already released self-contained lighting controls for lights in commercial spaces. You never touch it. You commission it with a wand, you point to the lights that will be in a network, you hit one button, and they commission themselves. They figure out where they are, where the windows are, whether there's a light at that moment, whether there's motion, you don't do a thing, and you leave it. Let me mention 3 companies' names that you guys didn't have the benefit of because they didn't exist: Nest, Silver Springs, and Box. If you put those 3 companies together and you assume everything will be done in the cloud, you don't have to touch anything. You know Nest has figured out some of the algorithms. You know Silver Springs, well, you may not know them yet, but you will, understands how to do networks outside because they do the smart meters for California. And the Box is the cloud. And you put it in one place, you don't ever have to touch anything ever again. Now, whether we do something with them exactly or not is irrelevant. It's already done, which means we'll get there very quickly. And that's where it's got to go. And then the cost comes down even further. And as much fun as it was for you the last 20 years, you'll have to find some other problem to solve. But this is true for us in security. Same thing will happen in security. Same thing will happen in public address. Anything that's right now in electrical industry that you can consolidate with chips. The light is the conduit to the smart everything. So it's a really interesting time.
It is. And we are out of time for our panel today. In closing, though, as we hear a lot of these big ideas today, we talk about the creation or offline movement of nuclear power plants, these huge energy issues, then I want to remind you via this session that there is action that everyone can take, and that lighting is an actionable item where we've had some really great innovations that are now ready for prime time. So let's struggle with those big picture ideas today, and then let's take away something that's reasonable from a regular old light bulb to a networked system, and go forth and turn off the lights. And thanks to our panelists for their contribution. I hope that you found this valuable. Please do fill out those surveys.